Welcome to the Calculus on Y Canvas. Today we will go over how to take a derivative of parameterized functions. This will be a good practice for implicit differentiation as well. So if you missed the very first lecture on the implicit differentiation, please find the link below in the description. Let's say that you are given with these parameterized functions x and y in terms of t. They are x equals t minus t cubed and y equals 2 minus 5t. Perhaps these functions describe x and y positions of a particle at time t. Now you are asked to find the derivative dy dx. How would you find it? You could eliminate the t variable and transform these parameterized functions into a function only in terms of x and y. For example, note that this second equation can be written as t equals 2 minus y over 5. Then you can plug this into the first equation to get x equals 2 minus y over 5 minus 2 minus y cubed over 5 cubed. Then you can quickly notice that there is y cubed term. How would you get dy dx when y cubed term is present? It can be done, but you realize that it will be quite messy. So instead of taking explicit differentiation, we will use implicit differentiation. Let's go back to the original parameterized functions x equals t minus t cubed and y equals 2 minus 5t. We will take the implicit derivative of the first function, which gives dx equals dt minus 3t squared dt. Do the same thing for the second function, which gives dy equals minus 5 dt. Now to find out the derivative dy dx, simply put dy on the top and dx on the bottom, which is minus 5 dt over dt minus 3t squared dt. Note that dt are common factors on top and bottom, so you can cancel them. Then you get minus 5 over 1 minus 3t squared, which is the final answer. Easy, right? Let's look at one more problem. This time, the parameterized function involves trigonometric functions. That is, x equals cosine theta and y equals sine theta. By the way, as a side, you should be able to recognize this as a circle because cosine theta squared plus sine theta squared equals 1 by the trigonometric identity. So we get x squared plus y squared equals 1, which is the equation for unit circle. Anyhow, we are going to find the derivative dy dx using implicit differentiation without using the equation for a unit circle. As we did in the previous page, we first find the implicit derivative of the first function, that is dx equals minus sine theta d theta. Doing the same thing for the second function, we get dy equals cosine theta d theta. Now to find out the derivative dy dx, simply put dy on the top and dx on the bottom, which is cosine theta d theta over minus sine theta d theta. Note that d theta are common factors on top and bottom, so you can cancel them. Then you get cosine theta over minus sine theta. Note also that cosine theta is x and sine theta is y. So we get x over minus y, which is the final answer. All right. I hope this lecture was helpful. Don't forget to push the like button and to share this video with your friends. More calculus lectures will be coming soon, so please stay tuned and do not forget to subscribe. All right, see you next time.